Hello, I'm going to talk to you about parametric equations. Parametric equations are equations that link two or more variables with a common parameter. So often is the case that parameter is time in most contexts. But let's have a quick look. If y is equal to, t squared, and x is equal to t divided by 3, and the question asks us to find y in terms of x, it's not very hard for us to rearrange these equations and make the appropriate substitutions. Let's just use this equation, the second equation here, and substitute it back. So I'm going to make t the subject, so t is equal to 3x, and if we substituted this into the y equation, we get y equals 3x squared, which is 9x squared. And this is a really quick use of parametric equations, but the parameter is t. Now the questions can get more tricky. I could now, instead of asking what y is in terms of x, I could ask you to find dy by dx. One simple way to do this is to find the Cartesian equation, which is the equation where you have x in terms of y, or y in terms of x. Those are Cartesian equations because they only use x's and y's. But parametric equations use other variables. So to find dy by dx in this context, I could simply differentiate this element here, and we will get 18x. Now, that's really convenient, but often is the case that parametric equations don't have nice equations. So here's an example that will probably change your opinion on rearranging for a Cartesian equation. So if y is equal to sine of t and x is equal to cosine of t, I don't really want to rearrange for t and substitute because it's going to be pretty messy. Because if I were to, I would have t is equal to the inverse cos of x, and substituting would give me something quite scary. And I don't want to try and differentiate this. Sorry, that's meant to be an x. This is not something I'd be willing to differentiate. And so what we do instead is a lot more elegant. And this is given to us on our formula sheet. So dy by dx on our formula sheet is written dy by dt times dt by dx. I like to write this slightly differently. I like to write it as dy by dt divided by dx by dt, because that's a lot kinder to me. So let's work out each of these individually. Dy by dt is the derivative of sine t, which is cosine of t, and dx by dt is the derivative of cosine, which is negative sine of t. So here, dy by dx is cosine of t divided by sine of t. That is the derivative with respect to t, with respect to x, even though it's written in t. That doesn't matter, because now dy by dx is also defined parametrically as negative sine t, negative cos t over sine t, or some would like to write it negative cot t. And I think that's quite nice. Now, what we might need to do is we might need to find the second derivative of this. And for the second derivative, there's another very common trick. I will tell you that in the next video.